Hello everyone, this is Dr. Sanket Pisat and today we are going to take a look at this newly launched Histromat which is called as FLOMASYS VAC from the company Medifusion. This Histromat offers a host of different features as compared to the machines regularly available in the Indian market, and I thought it would be a great idea to take a look at some of these features and see how they are useful to us in our day-to-day surgeries. This is the front panel of the machine, an LED panel, a standard fluid inlet as is available with all machines, a fluid outlet, but an additional feature is the suction tubing attachment. When the machine powers on, it first takes some time to perform what they call as a machine self-test. This self-test is a kind of calibration of the machine to check for its pressure sensors and make sure that everything is okay before you start the case. So it says remove tubing from the pump and press OK for self-test. If you're not going to be using the machine for extended periods of time, this tubing has to be removed before the self-test is performed. But since I'm regularly using this, I'm just going to keep the tubing in place and let the machine perform the self-test process. Once the self-test is done, you can then select which mode you want to use it for. So you have options of hysteroscopy, laparoscopy, arthroscopy and urology. My primary work is going to be for this machine hysteroscopy, but I can also use it in laparoscopy as an irrigator. So let me select that hysteroscopy and you can see that it has got a very dynamic panel on the front with a lot of options to choose from. So we are going to see how these options, what these options are and how we choose between them. But first, before we start all of that, let us take a look at the actual assembly of the machine. So this is the inlet port. This is where the saline is going to get attached. You could use a wide bore tubing that is provided by the company, or you could use a TURP set, but I would strongly recommend using a Y-shaped tubing so that you can have two bottles which can connect one after the other. Then the pressurized saline will go into the outflow tubing, and this outflow tubing will then obviously connect to the inlet of the hysteroscope. From the outlet of the hysteroscope, you have another tubing again provided by the company. This can be sterilized by autoclaving, by ETO, or you could use another disposable tubing that attaches over here. So you see that they have provided us with two canisters. These two canisters are for attachment to the suction, and because there are two, you don't need to frequently keep changing. You can just keep on changing one and the other one will keep working. From the top of the second canister goes a tube which attaches to the machine itself, and therefore a separate suction machine is not required. The suctioning is inbuilt inside the FLOMASYS vac machine itself. So you can see this is the arrangement that you have to do before you start off. Now let us take a look at the panel per se. The top left figure over here shows you the actual intrauterine pressure, and like a CO2 insufflator, you can set the set pressure. Here you have the flow in ml per minute and you have the set flow. So you have actual pressure, actual flow, set pressure and set flow. I'm usually going to work anywhere between 110 to 130. So let me set that pressure and I can easily start off with a set flow of half a liter per minute, which is 500 ml per minute. Let us now start the flow. But before starting the flow, what you need to do is, all right, we'll also take a look at the buttons on the right. So you can see there is a suction button over here and you can set how much suction you want for the machine to deliver when you start the case. Now, typically when we operate along with an external suction machine, what happens is that there is no definitive pressure that you can set and you have to manually turn the machine screw in order to loosen it or to tighten it to increase or decrease the pressure. Here you can electronically set the suction. Most of the times 0.1 bar seems to be a good choice to start the work. You can also select and tell the machine which size of scope you are using. So you can alternate between 4 scope and 2.9 scope. So the machine understands exactly what amount of flow it is that you need in order to work. Let us now start. Starting always is with a process called prime. So in the priming, basically the priming is to remove the air bubbles out of the machine, and the surgeon also has to be alert though the machine is going to prime removing all the air inside the circuit. The surgeon always has to be alert and make sure that all the air has been removed from the circuit before the patient is subjected to, means before you start the hysteroscopy. This is a manual as well as a mechanical process. This cannot be delegated to the machine alone. When the priming is over and adequate volume has been delivered, you can start the surgery by pressing the start button. As you press the start button, you can see that the actual flow starts increasing and the intrauterine pressure will also start building up. Now, segments of this video have been recorded outside the body without doing actual surgery. So the pressure readings and the surgery that go on may not really match with each other, but that is just for demonstrative purposes. So I can work. As I continue to work, when I am going inside the uterine cavity, there is a mode called clear. This clear mode, which is on by default when you have to switch it off, or you could switch it on your own, gives a kind of extra boost for the flow of saline inside the uterine cavity. Typically, with insufflators, one of the problems that I have always faced is that the pressure sensor in other hysteromats reads a high pressure when you are entering inside the uterine cavity. Now, because of this, when you require a high pressure at the internal os to be able to negotiate your way inside, the machine actually senses high pressure inside the cervical canal as compared to the uterine cavity and therefore lowers down the pressure, making entry easier. This is where the clear mode really helps, and you can see over here I'm going inside the uterine cavity, and if I activate the clear mode and go inside, all the blood and mucus which is there gets dislodged by a turbulent jet of saline and gives me a crystal clear view inside the uterine cavity. So this is a case with a large submucous type 0 myoma. These kind of myomas also make the os a little bit patulous, the internal os, and therefore some leakage is always expected. Nevertheless, you can still see that I'm able to visualize the inside and I have been able to see both the ostia now, one after the other. So I know that this is what I'm going to do. Now, if I feel that I have some obstruction or I have some blood inside, I can switch the suction mode on over here. And this suction creates a continuous suction irrigation kind of system where the fluid will keep on getting suctioned inside the machine itself. If I then want, and I have already in a comfortable zone, I can switch the suction off and I don't need suction, particularly in this case, for example, where the os is patulous and I don't require continuous suction because that will simply deflate the uterine cavity. So you can see over here the pressure keeps on increasing and I can now work comfortably inside the uterine cavity. Once I'm inside, like I said, if you don't want the suction, you can turn the suction off and you don't require people to be monitoring two different devices. It can just be done at one single level device only. So the type 0 myoma now clearly seen, and now we'll start off with the resection. Now as the resection starts, you're going to have some problems. First problem is of the debris that accumulates. Second problem is of the bubbles and the blood which will come and soil the field. So they've thought of quite a bit of things in order to deal with this. For example, in this, you can see that the flow has already started. I'm not using the clear mode right now, but what I'm going to do is switch to the auto flow mode. The auto flow mode means that it is going to maintain the intrauterine pressure at the set pressure, come what may. Like a insufflator maintains the intra-abdominal pressure when you give it a particular set pressure. Auto flow means that the actual flow is going to get regulated as per the requirement of the patient, and the machine will do its best to keep the set pressure at 100 regardless of whether there is a leak or not. So that's auto flow. And then there is dynamic suction, which further adds to the magic of it, because auto flow and dynamic suction together, what they do is they give you the just the right amount of suction required to empty out blood and not cause fluid overload by taking away blood and saline from the uterine cavity. And auto flow and dynamic suction combined make sure that your intrauterine pressure remains as close to the set pressure as possible throughout the surgery. This allows you to be able to do the surgery peacefully without having repeated episodes of deflation of the uterine cavity, and at the same time it maintains that the excessive fluid will not be utilized and your patient has a little bit lesser chance of going into fluid overload. So you can see that with this mode combined, I'm doing type 0 myoma resection, and the fragments and the blood, they are not getting sucked away completely. They are still there because they are large fragments. But what I'm sure of is that I am getting a continuous suction. So my patient has less chances of fluid getting collected inside her body. And at the same time, the machine is also managing the flow, which means I neither have less of saline flowing in, nor do I have too much of saline flowing out. When my job is done and I feel that I don't need it, I can always, this is the clear mode. So you can superimpose the clear mode on the mode that you are already working. For example, if I'm already working over here, but I feel that there is a little more blood that is soiling the feed, I can superimpose the clear mode on this and get a turbulent jet to be able to override the blood and mucus temporarily. And when that is done, I can turn the clear flow off, or I could just keep it on all the time and I can resume my work, giving me a clear field throughout the surgery with minimum intervention by the outside assistant. Once these settings, though they may seem a little difficult to understand, are understood by you during the first surgery, things will become very, very easy subsequently whenever you want to do the surgery. So you can see I'm proceeding comfortably with my hysteroscopic myoma resection. I'm almost at the base now, but I can continue. Another important thing that we are always worried about when we are doing hysteroscopy is the concept of fluid overload. And though no machine is there which can reliably detect fluid overload as of now, the company has given an additional feature over here, which is called as approximate volume. So what it happens, keep looking at the figure over here. As the amount of saline keeps on increasing, the amount of saline passing through the machine, at every 1 liter, the machine will give a beep. So you continue the work, but you know mentally that you have used up 1 liter of saline. And because you're using suction, a lot of that saline may have already come out in the suction bottle. Therefore, by having a continuous monitoring of suction as well as the amount of fluid going inside, the surgeon really doesn't have to stop the case every now and then to calculate the fluid deficit. Again, remember that there may be some fallacies here, like saline which has escaped out on the floor, which has not come back here, saline which has escaped from the tubes into the patient's body, saline that has got absorbed by the body. But in essence, it does allow you to give you an alarm bell at every 1 liter of saline. So here, when it crosses 2000, again it will give me a loud beep, and therefore I need not halt the surgery every now and then. I can get an approximate estimate of what the fluid overload is and prevent my patient from going into fluid deficit. So you can see over here, this is the end of the surgery. The pieces also getting cleared out very nicely by the turbulent jet and the autoflow that I mentioned before. And you can see this is the end of my surgery. I've already reached up till there. Everything is clear. And the machine minimizes human error by frequent intervention. If you learn to use the machine properly, I think this will be a valuable addition to our OR in terms of patient safety as well as in terms of ease and convenience of the operating surgery. So that's it from me for this particular video. Thank you so much.